Well, thank you very much for hosting me. Um, I've been a keynote speaker at several UXPA events over the years around the world, but this is the first time I'm doing a webinar. Uh, so I'm happy to be here to share some of the concepts and give you an overview of my new book. And I spent a 35-year career in industry, and I think some of you may know a little bit about it. And I don't want to spend a lot of time talking about me. So if you want more information about me, you can just go to the link below, rcdous.com, which is the website for my little one-person consulting company when I'm not doing my professor gig. But after 35 years in industry and practicing as a designer and leading some of the largest UX teams in the world, so 11 years as the UX VP for Oracle and starting the UX team there, and 7 years as the global SVP head of UX for SAP, and almost 20 years before that, various important companies in the PC era and before that. I've been practicing and working on a bunch of methods that I had my teams use and I personally use. And when I started teaching about 8 years ago at San Jose State, in my sort of pre-retirement gig, I couldn't find a textbook that captured the techniques and methodologies that I had found so useful and that I had taught to various teams that I had led. So I promised myself after 5 years of teaching and basically experimenting, my usability test is the graduate students in the Human Factors Engineering program, that I would stop and write a book and document it to share with the whole world. And that happened, and I took a year off, and the book came out in January. So the beginning of the story starts here. And I hope some of you will come off mute. I like to make these webinars a little bit participatory, so I will be throwing an occasional question at you and pausing. So the first question really is, if you're a user interface designer, what's the first thing you do when you start to create a spec? Now, I don't mean research. So let's assume you've got great user research, you've done your discovery research, you've mapped it into your journey maps, you have the personas, you have all the requirements from product management. So you have everything you need, or at least everything you're going to get. And now you're looking at a blank sheet of paper or a blank whiteboard. And what were you taught to do, and what do most people do? So I will pause here and wait for somebody to come off mute, and you can give me the answer. And as a hint, it's a one-word answer. What do you start doing? Somebody be brave. Because I'm going to wait for an answer.
So I'm gonna read what people are adding on the chat. I don't know if people can unmute themselves. I'm not sure. So I'll read. So people are saying sketch, draw, create user stories, imagine, panic.
Yeah, right. Okay, so the first answer was the one I was hoping for. Sketch, right? You start to draw, and what you draw is basically biased by your prior experience as a designer, other things you've designed, products you've used, reference products in the marketplace, perhaps the competition. So we were taught that there's this magical moment when all of a sudden the designers, the generative creative folks, just spew out designs, right? They just emerge from the ether. And of course, what you're trying to do is lay out ideas for a possible future state of digital product. And I'm here to tell you, don't do that. And I'm contradicting, frankly, decades of design pedagogy. And I did study industrial design and architecture as well as HCI. So there is a better way to start. And that's what the book is about. You will still have to sketch. Don't panic, but don't do it up front. So semantic interaction design is a proven cognitive science-based method. It's scalable, and by scalable, I work on big enterprise systems for much of my career. I do a lot of medical products right now in consulting. And once you have any degree of complexity, this notion of just starting to sketch is really inadequate. And the goal is to actually be 10x better. And 10x I will quantify specifically for you, but I mean it in two dimensions. One is how fast you can actually generate designs, and the other is what the quality of those designs is. So basically, the value prop is incredibly straightforward. It's faster, better. Very simple. Now, I did not pull semantic interaction design out of the ether. It has a long history in the human factors genre of research, dating back particularly to Phyllis Reisner in the 1970s at IBM Watson Research. The notion of grammar and human-computer interaction as a communication, and what was called the task-action grammar that was developed, and this actually predates graphical user interfaces, and is also paralleled in the psychology of computer programming literature, looking at the grammar of computer languages and how difficult they were to use and learn. In parallel, but a little bit later, also, the cognitive science track emerges with the stages of action theory by Don Norman, Jim Foley's work on the notion of design by levels. If you don't know who Jim Foley is, he's now a retired professor emeritus at Georgia Tech. Jim Foley and Andy Van Dam invented computer graphics as we know it today, almost 40 years ago. And both Jim and Don have read the book. Because I've had communication, and yesterday I got an email from Ben Schneiderman, who's also important in this story, saying he was up to chapter 3, and was very favorable. There was also a movement in the 90s around object-oriented user interfaces as everything went to C++ by a gentleman named David Collins. There's no particular cognitive science in here, but there is some similarity in this approach. The foundation is related. In 2012, Jeff Johnson and Austin Henderson published a book called Conceptual Models, which lays the foundation for semantic interaction design. Both Jeff, who you've probably heard of, and Austin, who you may or may not have heard of, were on the original Xerox PARC team that invented the graphical user interface. What I've done in UX Magic is to turn this into a complete system in pedagogy, where everyone else stopped at the grammar level of the task action model. I have taken it to a complete system. So what are we going to do today? Well, I hope you're going to learn about this new method. And as I said, the value prop is better, faster. Faster means fewer iterations, fewer meetings, more science-based trade-offs, and effectively a 10x efficiency in design. And when I say better, I mean lowest cognitive load. Lowest cognitive load generally would have the side effects of having the shortest flows and the minimum number of screens. Now, 10x is a very audacious claim, and audacity is the first chapter in the book. So let me tell you two stories. When I joined SAP, so we're now talking 15 plus years ago, SAP had a really crummy customer relationship management software product that had thousands of screens and was certainly not a success. And they were even not fair to call it a user interface or experience because it was just a bunch of forms that did puts and gets to the database. So the first iteration of modernizing this, using the legacy backend but going to an HTML front end, was able to reduce it to hundreds of screens. And then a subsequent rebuilding to the cloud in a modern software model got it down into the 10s or 20s plus an iPad app. So in this particular case, we're talking about a really significant decrement in complexity, right? That's over 100x reduction in the number of screens alone. Now, I'll tell you about another case, more recent. These are some screens from a legacy electronic medical record system from Varian Medical Systems. This system is for managing radiation treatment for cancer. And It was at over 800 screens, and I worked for several years as the UI architect on this, and we generated a new design, and these are some sample screens, and I use this product as one of the case studies in the book. What you see now is the landing page for a doctor, which uses cards that sort of represent an Internet of Things set of objects related to events and actual lab results that are flowing in, looking at the aggregate view of all their patients. They look at a specific patient, they get an overview with a social pattern, with a feed of these Internet of Things cards, plus all the conversations running in parallel. And then there's a screen that looks kind of like a medical chart that's pretty typical. And so going from about 800 to 45 screens, most doctors actually only need 5 of them to do their work. So this was an improvement in around 18x, right, in reduction of screens. However, that's really a gross understatement because the original product only supported radiation treatment for cancer. The new product supports chemotherapy, surgery, genomic medicine, and has a full decision support system, including things like clinical trial matching, et cetera, et cetera. So while it looks like the improvement might be 18 or 20x, it's probably at least double that because the functional scope more than doubled for the new product. So those are some proof points that I can share. I have more, but some of them would require everybody to sign an NDA. Okay, when would you do this? Where are we in the UCD cycle? So every UX team has some diagram that looks like this one. I borrowed this from an old SAP slide when I was in charge there. But you'll do your discovery research, you have a design phase. Post the design phase, you'll be adapting, iterating, measuring, and usability lab of the field. So UX Magic is about being a Jedi in the design bubble. This is not a full life cycle book. I'm not going to tell you all about discovery research. I'm sure almost everybody who's on this webinar is an expert in front end and back end user research. So just this bubble, very focused. And that's the weak link. Why? Because design Darwinism simply doesn't work. Design Darwinism is this mistaken belief that you can just A/B test your way to quality. And it's really a joke. And in fact, there's a great book I just started reading by Daniel Jackson, who's a professor at MIT, called Design by Concept. And he really hammers the point that quality is not about, real quality is not about eliminating defects. It has to be properly designed from the start. And none of these trial and error methods scale. You don't A/B test and see how many patients die in a medical product. So how do you do this? I'm going to break this into 2 parts, explaining the how, the theory and the practice. There's 2 cognitive science principles, and they operate at 4 modular levels in terms of creating a UX specification. I'll speak about the principles in a minute, but I want to introduce the levels first. So there's the semantic grammar level, the visualization, which means design pattern selection, flow, because the design moves through time like a movie, and optionally game theory, where you are trying to incentivize people to do very specific things as part of your design. So I'll talk about the 2 principles now. I can summarize it pretty simply in 1 slide. For human beings, language is the basis of conscious thought. It's not the basis of all thought. Our primitive lizard brain deals with the fight and flight mechanism and emotions and things like that. But whenever you have to do a task over time, solve a puzzle, do anything with any complexity, you have to think about it in your natural language, usually your mother tongue that you learned as a child. Then we know from linguistics that there is a correlation between grammar structure and cognitive load. And we also know this to be true for computer languages, if you're a programmer. Now, cognitive load can be measured in the usability lab. If you don't know how to do this, you can ask me in the Q&A. It's actually not that hard. But what's new is that cognitive load for an interaction design can actually be predicted in advance and managed in advance, and that's what semantic interaction design is about. So let me kind of clarify some of my terms here in terms of semantics. When we talk about the grammar of a human-computer interaction, if you look at the classic GUI, which all of you are familiar with for sure, you would see actions living in menus, and you'll see objects that you can click on in a canvas, for example, and objects have attributes like colors and fonts, right? This is the basic premise of graphical user interface, that the world can be broken up into recognizable objects, actions, and the attributes. Now, if you go a little bit forward, let's look at the relationship and some measurements. In my career, I've had the opportunity to redesign or design from scratch several word processing products. And actually, the first two were in DOS, so it tells you how long ago it was. And they were horrible because while users would recognize the notion of a character, a word, a paragraph, a document as things that they were working on, the objects, right, the actions were very redundant, and they were all mapped to various function keys and command key combinations, and there was not symmetry. So you'd have, one function key to remove a character and a different function key to remove a paragraph, et cetera, et cetera. And so you had a pretty mediocre grammar, and I call this the sparse grammar problem, right? It looks like Swiss cheese. There's exceptions and there's redundancy, and sparse is really, really bad. Now, in a perfect world, right, there would be no redundancy and no exceptions. And so you could have the same grammar, which you've probably come to recognize now, of like cut, copy, paste, not only applying consistently within a given application, but of trying to be applied consistently across an entire operating system and all the applications that are in it. So I think it kind of goes without saying that the dense grammar, which you would push in your communicating in your design, is going to induce a lower cognitive load on users than the sparse one. But my question for you is, how much worse is that sparse matrix than the dense one? Is it twice as bad? Is it 1,000,000 times worse? So I'm going to pause and have another sip of water, and I'm going to wait until I hear some numbers. So just throw out, what do you think the difference is? And then I'll show you what the math looks like.
And I believe everybody can unmute now. So let me know if you cannot.
Somebody be brave. Give me a number.
I'll share what I see in the chat. 10 times, 10, 5 times.
Okay.
20 times.
All right.
And people are having a hard time unmuting. Sorry about that.
Okay. Let's look at the math. So if you had a perfectly dense grammar, right? No inconsistencies, no redundancies, no exceptions. Essentially, cognitive load will grow at the rate of the number of actions that the user must recall plus the number of objects. As the matrix gets sparse, the math turns exponential, and it's the number of actions times the number of objects. And so it gets really bad really quickly. Now, one of the questions that does come up, so I'll answer it in advance, is what's the inflection point of this curve? And the inflection point seems to be, based on our research at the university, about 20 to 30%, because there's no perfectly dense matrix. But if you can hold yourself to no redundancy and about 30% white space or less, you can pretty much flatten the curve, which seems to be our favorite term these days. But that's the math. So when grammar gets sloppy, it's a disaster. Now, if you look at a real example, okay, this seemed interesting in theory, let's look at the 800 to 45 screens. So here's what happened. This is the matrix that describes the grammar that could and does actually cover pretty much all forms of cancer treatment. The objects that need to be understood are the patient, the medical record, the treatment plan, and then a bunch of operational stuff like appointments and tasks, and then the notion of a care team, which is at any given point the group of clinical practitioners working on the patient's case. And then you need about another 10 actions like create, update, void, because you don't delete anything in the medical product. And then because there's some workflows, there's accepting and rejecting and delegating. And then there's referring the patient to other practitioners and transferring the patient from one medical institution to another, et cetera. But effectively, 10 objects and 10 actions can't describe an entire EMR system. So, in practice, how do you get around to defining this grammar? And then how do you manage it across all 4 of the levels, right? And keep it from getting complex. So I'll start with the grammar layer. Well, objects and actions come from natural language. In the object-oriented UI movement in the 1990s, they had a concept called foraging for nouns. So you're looking at all the possible nouns that you can find that describe the tasks. These a noun maps to an object, a verb maps to an action, and any adjective would map to an attribute of a given object. It's really that simple. And then, now that you understand what I mean by grammar, I'm going to step away and talk about the process, and I'll come back a little bit more on grammar. So assuming we can define and refine to the smallest set of objects and actions that we're going to make our graphical user interface sit on, then we need to enumerate all the attributes for every one of the objects, and we need to prioritize the object-action pairs because they are not all equally important to the user or to the business. Now, let's look at foraging for nouns. In my class, my first class in interaction design at San Jose State, the intro one, I use a pet rescue case study. So we're trying to basically get dogs adopted. Think of the Humane Society in every city in the United States as a kind of model, and they have these in other countries as well. And because most people are doing Agile, the easiest place to start is user stories. And you would have user stories about the pet adoption process. And you can just highlight them as a parent. Okay, person object, I want to find action, a friendly attribute, dog object that will teach my children, person object again, to be responsible. As an elderly widow, person object, living alone, I want to adopt action, a dog object for my protection attribute. And so you can use a traditional human factors task analysis. If you're still doing waterfall, you can use your use cases and scenarios, but fundamentally you are looking for nouns, verbs, and adjectives, and the cumulative set of a user stories in Agile does define the complete scope of a product release. Now, after your foraging activity, you can start to create the matrix, and it will be sloppy, right? You'll have all your candidates, but that doesn't mean you need to use all of them because it'll be too complicated. So what you end up doing is finding a bunch of candidates for objects and actions, and then you try to pivot as many of the objects to becoming attributes of a smaller set of objects, and any action that can become a state change for an object, therefore can be pivoted to being an attribute. So basically you're trying to pivot both objects and actions to become attributes of the smallest set of objects possible, which would leave you with basically all I really need to do in the user experience is say, have a dog as a recognizable object, people, the potential owner, understand themselves and their profile, represent the organization and deal with money. And then donate, adopt, schedule to meet and pick up your dog, etc. And so just very quickly, in a matter of maybe an hour or two, we can do a quick compression from maybe the original, which would have a scalar cognitive load value of 66, and push it down to 9. So this is a 7.3x improvement And what we do find in class is we look at a couple dozen of these pet adoption sites around the country in the United States. And on average, they have between 200 and 300 screens. And then we start over with a clean sheet of paper and a brief that has even more functionality in an AI-based matching system. And the students redo that as a project. And on average, it takes them 20 to 30 screens to do the entire functional scope. So again, easy to get a 10x or better. Then you have to figure out the object attributes. And this is a very small table. Even for the pet rescue, it's a much longer table because an animal, right, would have a species, an age, a breed, a personality. So, and you need to know whether it's exercise friendly or kid friendly. So it has a lot of attributes that will be necessary to match it to the customer, right, a potential adopter. Now, from a cognitive science standpoint, this is really important. Attributes don't add significant load. Right? When we deal with attributes in a graphical user interface, we're relying on recognition, human memory, not recall. And humans are the best pattern matchers, and we store very complicated hierarchical ontologies of attributes on all kinds of topics. And it just simply doesn't add significant cognitive load, so you can more or less leave it out of your calculations. And then, as I said, we prioritize because not every task is equal. And task, if you come from a human factors background and would think of a human factors task analysis, in this context, a task is equal to an object plus one or more actions being applied to it. So what does it look like? Well, there's two dimensions, right? When you got to prioritize. Frequency, how often do people do it? And volume, how many people do you want to do it? And remember, and I should have said this earlier, that the conceptual model in the grammar is what you as the designer are pushing out. Do not confuse this with the notion of mental models from Don Norman, the a priori kind of assumptions that users have about whether a door opens by pushing or pulling, right? This is the language you as the designer are going to push and rest your entire design on. So you decide what you want most people to do most of the time, and this should be extremely prominent in your designs that you do. And obviously there are tasks that many people do, but they do it rarely, like creating an account. And you still have to get them to do it well, or you're in trouble. And then for consumer products, I recommend a financial row or column, your choice, to segregate things like micro revenue, like advertising driving money on a click versus shopping cart clicks or paid subscriptions. Don't mix that in with the actual user's goals, because the user's goal is not to see your advertising, for sure. So if you stopped at this level, then here's some things you could do, though we will go further. Number one, from a user research evaluation standpoint, I suggest that this is probably the best heuristic evaluation method because unlike the kind of one proposed by Jacob Nielsen decades ago, which we still rely on, and with all due respect to Jacob, I co-authored a book with him in the 80s, we're good friends. This is a more quantitative way to look at the effect of the grammar not working and having a lot of exceptions. Then, assuming you can retroactively determine the grammar that the UX is communicating, you can look at how that maps to the user's mental model of the domain and their task. Number two, if you're designing on a clean sheet of paper, this is the absolute best way to minimize cognitive load and start on the path to minimum screen count and shortest flow. And obviously prioritizing the tasks before you start creating mocks saves a ton of time, because usually the first 2 or 3 iterations of mocks are all about actually figuring out the priorities and discussions and more discussions with product management and other stakeholders. And I actually teach this prioritization method to product managers at companies around the world. Number three, if you're dealing with the evolution of an existing product or service, add new features as attributes of existing objects. This will minimize the growth and complexity due to feature creep. So try to do everything as an attribute and never, if you can avoid it, introduce new objects in a legacy system. Now, let me move to the visualization layer. Visualization layer is long, excuse me, is the longest chapter in the book because it explodes into its own levels and what I call, these I call layers, these I call levels, but probably a distinction without a difference, right? When in design patterns, we have our own hierarchy. And the question is, as you go into the world of visualization, are you minimizing cognitive load? And the way you minimize cognitive load is by being very mindful and consistent in what patterns are assigned to represent objects versus patterns assigned to represent actions. So just to make sure you understand my terminology, I refer to components as these raw materials like a button or a label. Once you start to assemble them, they become a widget. And so just with buttons and labels, we start looking like something you would recognize. We add a few more controls and we have a bigger widget, and all of a sudden it's functional as a date picker. And eventually this grows into the calendar archetype. And archetype means screen template, or if you work for SAP and the Fiori UI standard, it's called a floor plan. But these are whole patterns that everybody would recognize. So let's look at this and walk through the patterns. So components, there's about a dozen that are the most common. And most of these GUI components were invented by Jeff and Austin and Larry Tesla and other important people a long time ago at Xerox PARC to represent attributes. A checkbox represents an attribute state of an object. A button was designed to represent an action. An icon generally can represent an action, but it could also represent an attribute state if it's going on and off. So the main point here is be incredibly mindful and consistent and never use the same control to do more than one of these things. And if you're writing your own design standards, UI guidelines or design language, as people like to call it now, you would remove 50% of the X's in this grid. I'm saying these are probably allowable, but you don't want to do more than one. Look at some examples. The menu. Here's an example from LinkedIn that actually works, right? We have a menu of cards that represent jobs, and we have we also have somebody who needs to mute. Yeah, we're hearing the kids running around. This could happen at my house too, but it would be grandchildren. Okay, and we have a menu holding actions. And these are fine to have these two kinds of menus with different controls in the same system because they're visualized totally differently. But if you visualize these jobs using this layout and just the words, you'd have serious cognitive load. But let's pick on Yelp because Yelp has got some real defects. So here we have these tabs, which, by the way, I did invent tabs. That is true. You can ask me about that in the Q&A. The patent is so old, it's expired a decade ago. But anyway, we have tabs representing these two views, the inbox and the sent messages. But here, this third tab is actually a button. This is an action button, not a view control. And it's got the same color and the same shape of the tab. So this is a semantic error. I'll show you some more at a different level. Widgets. We have a bunch of widgets. Cards, tables, forms, filter panels, property sheets. And again, these guys were set up in life to represent attributes, actions, or objects. Most of them start to, once they have data in them, represent some object and object relationships. And occasionally they can represent an action. Again, you need to be super mindful. And in this case, in your design language or following operating system guidelines, remove 70% of the X's and be hyper consistent. So let's look at an example again of an error. About 6 months before the book came out, I got an invitation from the Google Material team who had heard about the book and the fact that actually I use Google Material for the cancer treatment system. to get a preview of the book. And the Google material design is billed as a visual language, not a semantic language. And it's full of these kinds of errors. So here we have a card representing an object, in this case a restaurant. And boy, don't we wish we could actually click on that and make a reservation for dinner, something we used to take for granted. And it has a local action in the lower right corner left corner called reserve. And here we have a card representing attribute, the weather in Hong Kong, and it has, again, a local action in that same position. They both have the same color, font, face, etc. But this one is actually transactional, right? This actually makes money move. And this one is just a view control. And it's not relevant to the grammar. It doesn't move the flow forward. So this is an example of a semantic error inside a widget. And we had to get rid of a whole bunch of stuff like this in Google Material because, and I'm not over-exaggerating here, a semantic error like this could kill a patient. People aren't paying attention. Now, my widget list is relatively short because there's a lot of widgets that aren't grammar relevant. So for example, if it's a container like a dialog box or toolbar, that neutral container takes on the grammar of the controls that are in it. And controls like zoom, pan, and scroll don't matter, nor did that expand or contract, because it does not move the transaction forward, right? It's just changing a view in the model view controller of the graphical user interface. And then we move up to archetypes, and you'll see the same kind of table, right? Most archetypes are page template types that we would recognize, like a shopping catalog or a menu or a funnel pattern like TurboTax or Amazon shopping cart checkout, a desktop, a portal, social, a workspace for writing code. All of these have an optimization by their inventor, and I am the inventor of at least three or four of these, that they were intended for, and humans will actually recognize them as designed for that intent, right? Again, don't use trial and error, right? Don't throw darts at the dartboard to decide which ones to use. And then also, again, knock out 70% of the X's here when you use these in your designs to be really, really consistent. And also, in general, be consistent with the industry de facto standards, like doing a shopping catalog, Amazon, or doing search Google, unless you can do something much, much better. So let's again be really practical and look at Facebook. Facebook has global actions at the top, sprinkling of local actions, usually in this right side panel. The main objects are people and conversations, and content is just an attribute of something, right? The raw content in the post is always an attribute, and in this case, it's a common attribute of the conversation and n number of people. But at the left-hand side, it's kind of screwed up, right? So here, with the exact same visualization in this panel, we have objects, actions, a bunch of attribute filters, and some more actions. And I know Facebook just changed this a few weeks ago, but it's still, in my opinion, suboptimal. So again, to me, this is not a good design in terms of grammar consistency. Now, those are very static views at the visualization layer. So I want to get to the language. And once things start to move, are you absolutely consistent in how you're expressing the grammar across the different design patterns? So here I'm going to fall back into my case study with the electronic medical record system, and we're going to do a day in the life of journey of an object and an action. To refresh your memory, this was the conceptual model. First, we're going to look at an appointment. This requires no medical expertise. Landing page for the doctor was that swim lane. I cleaned it up to make this really simple to understand, right? We have an appointment represented as a card. It's a primary object. Every card in the system is an object. You click on that card, it expands. Now, inside the card, we have attributes both about the patient object and the appointment itself. So this actually is dealing with multiple objects. And this is real important to doctors. It may not seem obvious, to have the cancer staging in the appointment, but as the doctor's running down the hall, doing 20 and 30 consults a day from one room to another, they want to look on their phone at the appointment and get a quick update on the patient 10 seconds before they walk through the door to say hello. But then looking at the semantics of the actions, every card has a local action menu. The local action menu is optimized for the persona. In this case, creating a task would be the most common thing for the doctor. He's going to tell somebody on the care team to do something either before or after. Go to the calendar archetype in this EMR. The user here is usually the front desk person. The appointment object sits the same. It has a local action optimized for the front desk person. So the most obvious thing is either sending a message to the patient, remember to do XYZ before you show up. Could be create a task, but they will be able to cancel the appointment, something a doctor would never spend time doing. And then if you go into the patient chart, right, so now we're looking in the full medical record object, the appointment card is actually embedded in here, and it's the same card. However, the patient information is moved to the header. So what was a local action just on appointments is now a global action that applies specifically to the patient. And it applies to everything else in the page, but otherwise the object is represented identically. Now we'll look at void. This one is a little bit more sophisticated. How does the void action flow? So in medical records, if you make a mistake, you strike out the error. You never delete it. If you were to delete data in a medical record system, the FDA would shut you down. So there is this include voided filter, because most of the time, unless it's a forensic thing and the patient died, nobody is going to look at the voided data. So I'm going to pause and now again go into the chat, perhaps, and tell me what the medical error is in the screen, right? You don't need to be an MD to figure out what's wrong here. Anybody see the error? Just look at the header.
I am guessing including the voided data.
Well, we haven't seen any voided data. Right now, we're looking at 2 cancer diagnoses for one patient, and the patient's female. However, there's a prostate cancer diagnosis. So unless this patient has had gender reassignment surgery, in which case they would still have a prostate, but it's actually in a very different location than it was before, this is a medical error. So for purposes of our day in the life, let's assume this is in fact a medical error, and therefore I would click on the card for the prostate surgery, and this was probably an intern who was drunk, who made an error, okay? Hit void diagnosis, it's struck out. If we uncheck that filter, it's gone. And now we basically are where we should be, which is essentially a breast cancer diagnosis for a female patient. Click on the card and the card opens. And this one is a very complicated card. But I showed this to you because this is all the cancer staging, which I'm not necessarily going to try to explain. But where the void action before was global for the entire diagnosis, there's many, many parameters, many, many attributes for staging the cancer. And you need to have a void action at the local level as well, in case somebody makes a mistake, because this could be done over a couple of days looking at multiple pathology reports. So again, actions do exist in many systems at the global level and at the local level, and also in that dimension, which I haven't talked about yet, there needs to be very rigid consistency. But let's move on. Okay, we go to the Documents tab in the patient chart. If somebody imports a pathology report for a different patient, it's a medical error. And therefore, you would have the same void behavior to pick that document out and say, this doesn't count, get it out of here. And if the doctors and nurses are leaving free-form notes, it's called a journal note, for each other about their impressions of the patient and what to do next, and I type something incorrectly, again, I void it with the local action, and once it's voided, it cannot be undone. That would also have the FDA shut you down. So then you would basically have to retype it if you did unintentionally voided something. So that's really a day in the life, but you can see how that kind of hyper consistency makes it pretty easy for doctors and nurses and even the clerical staff to flow through that system now. And again, 45 screens instead of 800. Now, I want to talk briefly about architecture. There are 5 fairly common UX architectures. Think of box equals a screen, and a screen holding one or more objects. There's sequential, like the checkout sequence, hierarchical, which you'll recognize from almost most web pages, hub and spoke, works in media and a lot of enterprise apps. There's something called the matrix pattern and then a network pattern, where you can go anywhere to anywhere, from any object to any object, but it has to be really smart and know the relationships and the context between objects. And objects have relationships. They can have many to many, one to many, many to one relationships. And that has to be understood in all these. The key point here, and this is an entire lecture by itself, is there's a strong relationship between tuning the grammar and the architecture that you choose. So all of these architectures have a set of 8 human factors, characteristics, from location awareness down to efficiency. Obviously, sequential flows have very high location awareness, but they're pretty inefficient, as opposed to the network, which can be extremely efficient, but you need to have really, it's going to have lower situational awareness, so you would never use this for a product that is infrequent. You would only use it for professional product that people are in several hours a day and know the domain. So when we did the electronic medical records product, we actually looked at hierarchical, hub and spoke, and network right away while we were working on the grammar. So we're working at the top of the food chain and the bottom, and we're tweaking the grammar because the network, for example, has to have fewer objects. It kind of explodes in complexity at the navigation level if you have too many. So there is an interaction between all of these, and in reality, what you need to do is iterate on that whole triangle, right? While I teach it from the bottom up, we sometimes practice it at the very top, very bottom, getting those aligned, and then work in the middle. Now, who recognizes all these patterns? The answer is 5 billion people. Thanks to the internet and smartphone penetration, everybody looks at those archetypes and those widgets and those controls and has an a priori idea when they're assembled into a screen what they're going to do. They expect the filter panel for shopping to be on the left, right? They expect advertising to be on the right in most patterns. They have an idea when they see a screen for the first time, whether it's a dog or a cat or a zebra. They're going to pattern match at that level. Interestingly, the other 2.7 billion people on the planet, whether they're literate or not, and by literate I mean can read, can only interact in the HCI world by mapping physical world metaphors that they understand onto potential objects and actions on the screen. And if you're going to teach anybody to become digitally literate, you can only teach them by using a vocabulary of nouns and verbs to explain what's going on the screen. So for most of us, we work in that first 5 billion because that's where the service economy and the money is. But I do not mean to imply that the other 2.7 billion are not worthy of our attention. Then that gets us through most of the pyramid, and in just a couple minutes, I'm going to touch on flow and game theory. So if we go back to the dog adoption, we take a really simple flow, right? We just want to collect donations because it's a nonprofit, right? The donate action is could be related to a dog because you can donate money specifically to feed a particular dog, even though you aren't able to adopt one, but you're a pet lover, You're the person, potential owner. There's the organization, which will receive the donation, and obviously the money, which is the object that's changing hands. And if you, again, look at the diagram and assume boxes represent objects and lines represent actions, right? Just like Jesse James Garrett it kind of taught us all 20 years ago and how to do experience flows, and his old website is still up and it's still the best system, then the message is really clear. Actions propel objects through the flow. A box would be the home screen, right? We'll have multiple objects, happy owners and dogs ready to be adopted. There'll be a donate call to action button. You click it, you move to the money object, AKA the donate screen. Maybe there's a proxy for donate, which is a volunteer, an alternate attribute. Click the pay action, you get to the thank you screen, which is all about the organization. And then got to move the user someplace else. If you know who they are, you might go on one path. If you don't know who they are, you might go back to a different version of the home screen. But fundamentally, in experience flow, actions propel objects through the flow. That's how it works. And so what I tell all my students to do, and I do myself, is even before drawing a sketch in the screen, for the high priority box in my prioritization matrix back in the grammar, I would lay out the flows for every high priority action object pair. Then game theory. Can you motivate people to favor particular object action pairs? In the field of game theory, as applied to interaction design, there are three flavors of game theory. Gamification, which is the addition of reward elements to incentivize productive work. Gameful design, where you create a proxy game for a transactional task. So imagine in your head, it looks like Tetris, but when you get all the pieces filled into the right shape, you get your expense account reimbursed. So you're actually doing a physical task, transactional task. And then captology, which is the work of, say, B.J. Fogg at Stanford over the past 2.5 decades, about using technology to persuade people to do things. In pure games, our goal is to raise cognitive load to the highest level that the user can overcome. But in these other flavors, we want to continue to minimize cognitive load. We're not trying to make it harder to do the task because we gamified it. So how does this relate to grammar? This is the second longest chapter in the book, but it comes down to the following. In the gamification flavor, you as the designer are specifically providing action incentives. In gameful design, you are doing an object substitution with a proxy object for every transactional object that would still make the deal go through. And in captology, you are using attribute manipulation, like saying only 3 available at this price when the warehouse is full of that object, trying to convince somebody to buy now. Why do you apply game theory? Because you're trying to increase or decrease some human behavior. In the enterprise world, you're trying to increase productivity or performance, maybe decrease boredom if it's repetitive electronic sweatshop work, like being in a call center, right? If it's in consumer, it could be decreasing some unsafe behavior and increasing health and well-being. And I'll show you examples of both of those. In game theory, you're specifically targeting intrinsic and extrinsic motivators. Intrinsic is how we feel about ourselves and feel good when we accomplish something. So we have specific motivators like learning, love, and mastery. And extrinsic is basically how world will perceive us, and we believe we will be perceived in the external world. So the most common ones to target are fear of failure and greed. And competition is the most obvious one in that bucket. When you go in actually the world of game design in IXD, you'll have some system, and this is just a screenshot from the Nissan Leaf owners portal for their electric car, which is brilliantly gamified. I do not know who the designers were, but I'd love to meet them. Here's a competitive social game where drivers in different continents are competing with each other to create the largest carbon offset. And we're obviously targeting certain intrinsic and extrinsic motivators. But what you'll understand from the game literature is you have this notion of mechanics, like connection, narrative, privilege, reciprocity, right? These mechanics, and there's a dozen or more in the book that I focus on. In total, there's almost 30 in true game design. So how does a game mechanic relate to grammar? A game mechanic is a combination of a flow pattern and a visualization pattern, right? So all of these can be mapped back to the lower levels that I talked about. And game theory's everywhere. This is a slide legally acquired from Facebook, where you can see that Facebook's game design, it has the intent of inducing social pressure on predictability and scarcity. And these are the mechanics that they use, again, combination of flow and archetype and widget, to drive you through game theory to stay longer and longer so they can show you more and more advertising. And finally, I want to show you a use for good. These are some screens from the Blue Star Diabetes solution from a company named WellDoc. This is the first instance of digital medicine. This is a solution prescribed by your doctors, reimbursed by your insurance company, and it is legally a pharmaceutical. It has a prescription drug code. It's FDA Class 2, but not a device. It's a drug. And in clinical trials in multiple countries, it has been shown to reduce the A1C, the blood glucose level of a high-risk type 2 diabetic who's using it daily by 2 points. And metformin, the most common pharmaceutical for type 2 diabetics, can do about a 1.8 reduction on average. At 6.5, you're a diabetic. So if you're up in the 8s and you can knock it down 2 points, it's a really big deal. And you will see the notion of challenges and rewards. But what this very sophisticated system is doing is trying to get you to stay with your exercise, diet, mindfulness, and sleep program to keep you in the safe zone in terms of your blood glucose level. And this solution can kill a patient. It legally does and can dose insulin. So while insulin's not that common for type 2 diabetes, that's why this version that I'm showing you here, the RX version, needs to be approved by the FDA. And that's the end of the preview, and we're right at the top of the hour. So I've given you kind of the when, where, why, and how a little bit. I do point out you can also not only find me at the website in the first slide, but for questions. Don't forget the other steps, but UX Magic is about being a Jedi, right, at the design. So you can have really good user research, and you can totally turn out a mediocre design. So I live in California, very near wine country, and you know, we would say you can't make good wine from bad grapes. So if your user research is off, doesn't matter how good a designer you are, but you can actually make bad wine from good grapes. So if you have really good grapes flowing into the design, you can still basically screw things up and not get the desired result. There's more to the book than what I've talked about. I do also have a dedicated chapter about traditional graphic design, not the pattern selection, but pure graphic design, because again, you can screw up a good conceptual design with bad general purpose graphic design. There's a chapter about how does all this apply to style guides and design systems, and the myth that the current ones that exist today actually improve usability, because they're all incredibly weak, which is why I titled the chapter Myth. It's a myth that these are effective. And then a chapter called Chess, which is the kind of final rant by me, very short chapter, on the future of design and the design profession and UX in general. We've only scratched the surface. The publisher is the Interaction Design Foundation. It's a nonprofit in Europe that I hope you're familiar with. Go to Amazon, digital paper. It's not a small book. It's about 350 pages, full color. So all the illustrations and screens are full color. And there are exercises in the book to try and learn how to practice the method. And there's a whole system on the Interaction Design Foundation website for working with people on the exercises to really master the method, almost as if you were in class with me. Final addendum here for individuals. If you found this interesting and compelling, please tell your colleagues at your company or other companies and post on social media to help spread the word. My goal is for UX Magic to become the standard textbook for interaction design globally. And while that sounds like an audacious goal, I did it in the 90s with another textbook, Human Factors in Product Design, which was the first textbook in the human factors world that was focused on consumer products and not on military application. If you're not a member of the Interaction Design Foundation, please go there. It's very inexpensive, only a few dollars a month. There's a ton of great material, curated, not the usual garbage that's floating around the internet. And if you are a manager in a company of a UX team, number one, I do have corporate training, and I've had a bunch scheduled for the summer, and it's got moved to the fall for a number of companies. But in addition to material on this book, Semantic Interaction Design fits into data viz and information architecture, which are not covered in the book. But I actually have an entire semester where I teach my grad students how semantic interaction design is applied to minimize complexity in data viz and information architecture. So if you're interested in that material, I'm also happy to share that. And now we're done, and I will stop sharing.
Hey, Daniel, this is Jennifer with UXPA. We just wanted to thank you for putting on the webinar today. There are 5 questions we can send to you and let you answer, and we can send it out to all the attendees afterwards, unless you want to try and tackle them now.
Well, we were scheduled for 75 minutes.
Oh, okay.
So I'm happy to stay and answer questions online. And I can even go beyond the 75 minutes. My next activity is to go to the post office. So.
Can you see the questions down at the bottom?
Let me get into the chat.
In the Q&A?
So in the chat?
No, not in the chat. It should say Q&A.
Oh, yeah. Hang on. Okay. Yes, I can see them.
Okay.
Okay, from Claudia. I guess you've explored this, but have you done any machine learning algorithm to automatize the linguistic model, like natural language processing, in the interviewing and research process, for example? So the answer is yes. There is a startup here in Silicon Valley that is automating the book. So in theory, you would put in user stories and do the prioritization matrix, and it will generate the UX design, and it generates it all the way down to executable code in either pick your UI library of choice, like React or Material, and pushes the code to GitHub. So there is a lot of work going on, and this company was started before me, but I got involved pretty early in their formation. So a lot of this, there is machine learning that can be done, for sure, to bring this into a generative state. And then the second question, also from Claudia, is have you worked on this methodology on semantic environments, ontologies, and semantic formats? So the answer is not yet. You want to separate ontology to be able to do a recommender system, for example, in a user interface, and the ontology needs to be domain specific. And clearly, for certain user interfaces like the cancer treatment, the grammar is absolutely domain specific, patients, medical record, etc. I had a meeting with a company yesterday that basically was inquiring about a consulting engagement that would do exactly this. So if they hire me and you ask me maybe 12 weeks from now, I might have a real answer. But as of now, I haven't tried it. But I'm probably going to do it actually paired with Jeff Johnson. Okay, for Mary, can you speak to progressive disclosure based on frequency of use as a way to minimize cognitive load? And does progressive disclosure fit into the grammar? And the answer is absolutely yes, it does. At all levels of the visualization and the grammar, there is the opportunity for personalization and customization. And progressive, and that's covered in the book. So every one of those, everything, including flow, the last part of every chapter deals with the topic of personalization and customization. And not only is progressive disclosure in that category, there's about 10 other things that are equivalent to progressive disclosure that are covered that you could choose to be embedded in that triangle. Betty, will the deck be shared? I'm happy to send it to you guys afterwards, no problem, and this is being recorded. There's also a Medium article that's a nice overview that went with the book launch that that link can be sent out to everybody. Where can I get an overview on how to test cognitive load of a design? So for Mary, the basic, what you do is go into the psychology literature, academic literature. Pupil diameter, when you're eye tracking, is a scalar proxy for cognitive load. And there's a bunch of articles that show you, so you won't get an absolute value, but you'll be able to tell using an eye tracker, and it doesn't matter what people are looking at the screen, just use pupil diameter as a proxy. And off the top of my head, I cannot remember whether pupil diameter increasing or decreasing means cognitive load is going up, but I think it's decreasing. But check the literature. But it's a very not frequently unknown fact. And I've had a lot of students who've used this in their theses as a human factors indicator. Keith. Hi, Keith. I think we've met. Why do you call it UX Magic? So, because it's a joke. And that's, in fact, Jeff Johnson wrote the foreword. And so, basically, it's really like Penn and Teller, right? People think this is magic, but the show is to tell you how the magic trick really gets done. And so, it's a little bit of an oxymoron, but it was intentional. And it seemed like a much more interesting title than Semantic Interaction Design, which sounds very academic. Okay, William, you mentioned pivoting to reduce complexity, objects to attributes and verbs too. So when you pivot an action, for example, take the action publish. You could have a button to publish something in the system, or you could have a state on the object, let's say the profile of the dog, right? Where you just have a slider to say publish or unpublish. And therefore the action is actually accomplished by changing a state on the object, and therefore it's an attribute. So that's what I meant. Okay, and the last question, Lars. What resources do you think designers should focus on for future-proofing careers? What resources have you found to be thought-provoking in pushing your research work? Okay, so future-proofing is really the last chapter of the book, right? You need to play chess, and you need to learn how to play chess at the grandmaster level, because the cookie cutter, formulaic, you know, I just need to know Sketch and InVision kind of thing, which has become popularized by boot camp types of education, can be automated. This AI UX generator product is obviously coming to market will come to market in the summer, is focused on enterprise, where there's some very distinctly obvious patterns that repeat over and over again, and then it'll scale up from there to more complicated ones. It's not going to be able to do the cancer treatment system in my lifetime. So you need, as a designer, to be able to work at the high end of the food chain, or you're going to lose your job to AI at the bottom of the food chain. Now, as far as things to be focused on, you just have to read a lot. And the only thing I would say is this, and this is what I tell my students. I distill the knowledge into 3 buckets. Okay, there's knowledge about tools, like what's the latest tool. Do you use Sketch versus Figma or whatever the hell comes next? Because that's going to change every few years. There's trends like conversational UI, Internet of Things, and then there's durable knowledge. And I see many designers focusing on tools too much, trends too much, and not durable knowledge. So UX magic is durable knowledge. It actually works in AR and VR, but nobody asked a question about this. And when you pull out the visualization layer, you basically have everything you need to know to do conversational UX. But there's a complexity that's kind of beyond this talk about mapping to conversational UX. But focus on durable knowledge, not overloading on the trends and the tools, which is like eating too much ice cream and not enough protein. And again, I guess for durable knowledge, I would again say, look at what's available on the Interaction Design Foundation website, because that's curated, like the encyclopedia. It's not Wikipedia where everybody can be an author. I don't even have an article there. Okay, and I think I hit them all, but if, nope, one more. Agnes, looking back at website structures, you said some are more efficient than others. Does that depend on users' goals? Absolutely, right? The user's goals
Thank you.
will drive the grammar, right? And certainly the grammar prioritization. And then you have to look at what architecture would be most effective. Hierarchy is used the most because it's the most recognizable in terms of how it behaves. But if you have frequent users, it's generally speaking, it would have been horrible to do the EMR in hierarchy.
Right, so I was looking, I think you mentioned a sequential one, that it's not efficient.
Mm-hmm.
And I would have thought that if you have a clear user goal, saying calculating your taxes basically works like a sequential flow.
Yes, it's appropriate at times, and sometimes it's the only rational one to use because there are dependencies, right? So when you look at the user's goal, right, and the book covers this in detail, but I don't have it in these slides, you can break down the task into one of two categories. The task is either deterministic or it's indeterminate. So TurboTax is deterministic, right? You're the designer, you know what the goal is, and you know the definition of done. And therefore, you can really guide people and be sequential. Writing or editing a photograph in Photoshop is indeterminate. You don't know as the designer what the user's goal is, right? And so a serial architecture would be horrible and it simply wouldn't work in an indeterminate product. It pretty much needs to go with a tool in Canvas, like a word processor. So there's a huge intercorrelation between goals, grammar, and archetypes.
Okay, yeah, no, that makes a lot of sense, because when I was looking at it, I was confused by that. Thank you, I appreciate it.
Okay, so if there aren't any more questions, we can wrap it up. I will send the slides to be passed on. And as I said, if you, because this is a general organization, so I've done this like at Facebook, and I did it for IBM and SAP and Cisco in the last couple of weeks with the shelter-in-place order. But if you have your company and you'd like me to do it, I do not charge for this. I'm happy to repeat as long as the shelter-in-place order is in place and I'm kind of stuck at home. So feel free to reach out if you would like me to share this with some other part of your community. So thanks for inviting me.